Okie dokie pokey, we have a Monday morning, which apparently I just sang the Hokey Pokey song, and only one student knew the Hokey Pokey song. So today is Monday, October 17th, and I was away for a couple days, so you didn't get to see me very much, but we have this review of just a couple questions from each of the four sections in Chapter 2, each relating to our outcomes on rational numbers. The first question from 2.1 gives us two questions. It says, A, which is greater than, less than, or equal to? Is negative 2/5 and negative 0.4 repeating? Remember, this little line here means it's repeating. So if we think about what that means, it actually is the same thing as negative 0.444 dot, dot, dot. Right? That's negative 0.4 repeating. So our two options are we can change them both either to fractions or we can change them both into decimals. And we all agreed that when we did section 2.1, if we're going to compare them, the easiest way to compare them is changing both of them into decimals. That's right. So since I've already done converting the first one into decimals, I'm just going to change negative 2/5 to a decimal. Now, you can do it one of two ways. You can either think of 2/5 as an equivalent fraction with a 10, 100, or 1,000 as a denominator. Read that as 4/10 and write it as 4/10. Or alternatively, and definitely easier, you just take your numerator and divide it by its denominator, and you get 0.4 as well. So regardless of how we do it, we get negative 0.4 with zeros if you want, versus negative 0.44444. Now remember, when it's negative, negative 0.4. Oh, I did that wrong. Oopsie daisy. Let's try that again. Wasn't thinking. 0, negative 1, negative 0.5, negative 0.1, negative 0.2, negative 0.3, negative 0.4, negative 0.6, negative 0.7, negative 0.8, negative 0.9. Negative 0.4 even is going to be right here, right? Negative 0.4. And negative 0.4 repeating is going to be maybe right there. And the farther something is from 0, when it's negative, the smaller it is. So therefore, this number is bigger than this number, and therefore we're going to use this symbol to show that it is greater than, okay? And that's the proof we could have used on a test. We would have converted them both to decimals and shown on a number line that we understand that where those are represented, and we would be able to then say that negative 2/5 is greater than negative 0.4 repeating. Second question says, what fraction is between negative 0.2 and negative 0.3? Well, again, what we're going to do is we're going to add an insignificant 0 here. Oh. And before we think of a fraction between there, we're going to think of a decimal between there. So a decimal that exists between those two would be negative 0.25. And negative 0.25, you probably recognize it as a quarter, and you could probably write it like this right away. But if you couldn't, and you're like, well, I don't know what that is, you read that as negative 25 hundredths, which is this. And then when you reduce it to lowest terms by dividing both numerator and denominator by 25, you get that. So a fraction that's between there, negative 1/4 would be the best answer, but there are infinite answers of fractions between there. Any questions on that one? Our next question gives us 4 no calculator questions. Negative 2.8 and 5.3. Now, first thing we did when we did this was we estimated. I should have put estimate and calculate. So what's negative 3 plus 5? Our estimation is going to be roughly positive 2. If I think how I did this, I really say, well, what do I have more of, positives and negatives? I have more positives. How many more was the difference between them? And really what I did is I did 5 take away 3 is 2. And since they're positive, my answer is positive 2. That's how I did the estimation in my head. So we're going to apply that same principle to 5.3 and 2.8. We're going to subtract them. I'm going to borrow here. I get 5 and I get 2. So since I have 2.5 more positives, my calculation is going to be positive 2.5. For B, we're subtracting. Our estimation will be 5 take away 6, which is negative 1 as an estimation. If I think about how I did that, I really keep flip change a lot of the time, right? Keep flip change. I have more negatives than positives. So I'm going to take the negatives that I have more of and subtract the positives, which I have less of. My decimals don't line up, or my place values don't line up, so I'll put a 0 there just for poops and giggles. 5 take away 0 is 5. 7 take away 8 has to be borrowed, which is 9. I have 0.95, which of course is going to be negative because my estimation was negative, and I have more negatives than positives. So therefore, my calculation is negative 0.95. Our next question is the multiplication, so our estimation will be negative 2 times negative 2, which is going to be a positive 4 estimation. Now that we have our estimation, we can drop the negatives, we can drop the decimals, we don't need either one of them anymore. Multiply those out. 8 times 3 is 24, carry your 2. 8 times 2 is 16, plus 2 is 18. Second number, second line, second space. Put a 0 down there. 1 times 3 is 3. 1 times 2 is 2. Add. I get 414. Based on my estimation only, that has to be a positive 4.14 as a calculation. Only place you can put it. And finally, the last one, we don't have to estimate, just calculate. Remember what we did before? We said we have $2.40 divided into piles of 40 cents. How many piles of 40 cents can we make with $2.40? Well, with $2, I can make 5 piles. And with $2.40, I can make 6 piles. So my answer is actually positive 6. If I had $2.40 divided into groups of 40 cents, I can make 6 piles exactly. And since a negative divided by a negative is positive, my calculation is positive 6. Questions from 2.3 are our fraction questions. They're all pretty easy ones. The first one's 1/5 plus 3/4. When adding or subtracting fractions back in grade 7, you remember you needed a common denominator. In this case, 20 is the first multiple that's shared. The equivalent fraction to 1/5 is 4/20, so the same number. The equivalent fraction to 3/4 is negative 15/20. I'm just going to drop that negative sign up in the numerator instead now. It's wonderful. Now that we have that, we're going to keep our denominator and add our numerators. And what is 4 plus negative 15? It's negative 11 over 20 is our final answer for the sum. Make sure when you do your test, you show that step. It's important that you kind of get used to showing that so your teacher knows exactly how you got your answer. Next question, 5, and we're subtracting, which still requires a common denominator. We're going to use 10 here. The equivalent fraction will be negative 6/10. Notice I dropped my negative sign in my numerator. And the equivalent fraction to this will be negative, oh, I don't need brackets. What am I doing? Negative 5/10. Keep your denominator, subtract your numerators. Now I need brackets. Keep flip change. Final answer is negative 1/10. Negative 1/10. A lot of people probably made a mistake there, but just remember right here, at this stage right here, when I retranslated that to this, just take a note of how it looks and why it looks that way. And you'll understand how you got negative 1/10. And finally, we have our last question. We're going to do our multiplication first because that's what we do with BEDMAS. Does not require a common denominator, but we can't use mixed fractions. So we're going to go 3, 5, 5/3, which is negative. Cross reduce if you can, because it's lovely, especially here. 3 over 3 becomes 1 over 1, which means negative 5/8 is the product of those two. If you didn't cross reduce, you get negative 15/24, which is okay. It's no problem. My 1/4 drops down. The reason why negative 15/24 is more difficult is because you're dealing with larger numbers, but no big deal. 8 is my common denominator. Negative 5/8 and 2/8. Add the numerators. Keep-vous ton denominator. And your final answer for this. 2 plus negative 5 is negative 3. Keep your denominator. You get 8. Now this is the last one, section 2.4. We just started this unit, so this is kind of a review of what we did last class. If you've forgotten already, it's 8, no big deal. But remember the square root. Now if we go back into grade 8 and we say, what's the square root of 9? What that really meant was, what number multiplied by itself gives you 9? And the answer for that one was 3. So the square root of 9 was 3. Square root of 64 is 8. The square root of whatever. In grade 9, we learned about the square root of rational numbers in fraction and decimal form. But the same principle happens. What fraction multiplies by itself is 16/25, which is really not that hard. Because when we look at it, what's our numerator going to be? That's right, it's 4. Because 4 times 4 gives us the numerator of 16. 5 times 5 gives us the denominator of 25. So therefore, the square root of 16/25 is 4/5. The second question says estimate the square root of 0.46. In order to do this question, you need to know that the square root of 0.36 is 0.6, and the square root of 0.49 is 0.7. So if you don't have this number line drawn, you're going to get it wrong on a test. So make sure if you're writing this down right now, you're copying this number line down. And then you're going to take a nice little dot and estimate the square root of 46. So if I'm thinking about where that exists, right there looks about right. Maybe a little bit more over here, but somewhere around there, roughly, would be the square root of 0.46. And since I know the square root of 0.36 is 0.6 and the square root of 0.49 is 0.7, I'm going to put a 0 here and a 0 here just to help me think. I'm going to say the square root of that is roughly 0.67. Maybe. I have no idea. I'm going to grab my calculator to see how much of a genius I am. 0.46, I'm going to hit my square root button, which is this one right here. Ah, so close. 0.68. 0.68. That was close. The actual calculation is closer to 0.68. But again, we did that without a number line or without a calculator, and we used a number line to help us approximate the square root of 0.46. And finally, our very last question says, is 5 4/9 a perfect square? Our gut says no, right? Because 5 is not a perfect square. 4 is, 9 is, but 5 4/9 doesn't seem like it is. However, we did learn in our notes earlier that we can't calculate the square root of mixed fractions. It's much better to look at the square root of it as an improper fraction. 9 times 5 is 45, plus 4 is 49 over 9. And now we're like, aha, yeah, I see it now, right? Is 49 ninths? Yes, it is, because what fraction multiplied by itself is 49 over 9. My numerator is 7. My denominator is 3. So therefore, yes, it is. And what is the square root? The square root of 5 4/9 is 7/3, or better yet, 2 1/3.